Yeah, so moving on to talk more about like what Tinybase is and like how it differs.
Yep.
How would you compare it to things like Redux or like anything else that is like similar? So like what is Tinybase and what makes it unique?
All right. People often ask me, oh, how does this compare to X, or how does this compare to Y, or how does it compare to Z? It's like, oh, crikey, that sounds like marketing. Now I've got to go off and do like a matrix of like all the things that I do they don't, and all the things they do and I don't. To be honest, this was very selfish. I just built the thing with the API that I wanted, that felt natural, and I hadn't been able to find a version of. So, take it or leave it, folks. If you like my API, go for it. If you don't, no problem. But for me, the key thing was reactivity. You've gone to all that effort to use something like React, where you want the user interface to, react immediately to changes. But obviously, if your data's off in the cloud somewhere, like the immediately is not going to happen. So, like, how can I bring that data to be as close as possible to React, and how can I make sure that it's as amenable as possible to having hooks and listeners and all the other things that'll react immediately? Maybe I'm getting ahead of myself. Firstly, like, I'm not going to do as good a job talking about it as the website does, so definitely tinybase.org is the kind of source of truth. But no, essentially it's a little bit more structured, I think, than some of the other state management systems that you would see. I'm a bit more opinionated about how you store your data in there. So rather than just kind of some big JSON object or fragments of serialization all over the place and actions firing here, there, and everywhere, it's like, nope, it's going to go in a table, and a table has rows, and rows have cells, and like that's it, more or less. And you can change a whole table at once, or you can change a whole row at once, or you can change a whole cell at once, and you can listen to a whole table at once, or you can listen to a whole row at once, or you can listen to a cell at once, and like all the kind of the granularity works out. So if you're listening to a whole table and only a cell change, you'll get told about it. If you listen to a cell but the whole table changes, you'll get told about it. And so that kind of reactivity, regardless of how you're listening to something, is very important. By the way, it's not just tables. I now also have like a key value store in there as well. So yeah, you can have a set of values, which are always, by the way, strings, booleans, and numbers. So like you can't do anything too fancy. It's all pretty straightforward. But what I discovered is that you can actually build an awful lot with these two kind of paradigms. You don't have to let people do arbitrary, big, unstructured, unschematized JSON blobs. Like you can actually go a very long way with these structures. And so, yeah, for me, the key was using that opinionated data structure to its best. And you're getting the best out of the fact that I've made that constraint. So like making sure that the listener model and the reactivity is like as blazingly fast as possible. See if I can provide auxiliary functions that are a bit like what people might have wanted from a relational database. So I'll let you do aggregations on numerical data. I'll let you do indexing on textual data. I'll let you create relationships between tables like you can in a database. So it's not a relational database, but a lot of the things that you would normally do in a relational database can be done in memory, in JavaScript, on the device, local first. It's all blazingly fast. That's the idea. There's a few other bits and pieces in there. Actually, there's a lot in there too, but that's the basic idea. And I think the best way to sort of get a sense for how this actually works out is maybe looking at some of the demos in there. So we have like a drawing app, like an Excalibur kind of thing, where it's all local first, and you can have multiple windows, and you're moving them around, and they stay in sync. Analytics tools, client-side analytics tools, which is kind of an interesting thing. Databases of large amounts of data, like movies or cities, various other things. And it's kind of interesting to see, you can actually fit quite a lot into the memory of a browser. Like, it's pretty fast. And you don't really have to sit there waiting for a spinner all the time. Yeah, maybe there's a little spin at the beginning if it needs to pull down any reference data, but like after that, everything is like milliseconds, at least 16 less. So it's pretty sweet to see how you can push the performance of the reactivity, and I've been pretty pleased with how it worked out.
Yeah. Speaking of using the browser, what like technologies are you using to like actually store the data? Because I know like if you're using like IndexedDB or local storage, like each one has like different constraints and different performance considerations. So like what are you using, and like what are the performance characteristics of that?
So out of the box, Tinybase is just in memory. You instantiate a store in memory, and that's it. And someone refreshes the browser, gone. start all over again. So that's the default state. But then, of course, what you probably want to do is persist that. I'm not sure that's the best word, but that's the word I settled on. You either want to persist that or load from somewhere else that is already persisted. So yeah, the obvious thing is, can you persist that memory to local or session storage, and load it and save it. And by the way, I always try to have the loading and the saving of these things be also reactive. So in theory, if someone came in on some other browser tab or just hacked, the local storage, then Tinybase would detect that the change had happened and load the new changes into memory. So you kind of get reactivity all the way up the chain. Obviously, you can pull data from an external server, and so yeah. This is kind of where local first, isn't local only, right? It's, local first, but then also we're trying to keep stuff going in the background so that this is either being saved or persisted, maybe to the cloud, maybe to the browser, whatever. And I haven't done IndexedDB yet, and the reason I haven't done IndexedDB is that I can't figure out how to react to changes that have been made to IndexedDB somewhere else. Like, I can obviously react to changes that I was in control of myself, but if someone comes in and makes some other change, I can't pick it up, and that's very frustrating, because who knows, maybe there's some background service worker that went and made a change, but the UI doesn't see it. That's a big problem. So I haven't quite done that one yet, although I've got some ideas. But the big breakthrough in the last couple of months has been connecting Tinybase to Sqlite. So whether you are running Tinybase on a server, which of course you can do, and have it connected direct to Sqlite, or if you've got Sqlite running under WASM in a browser, then yeah, you can basically store and load your tables into memory from the database or save them back. And that is reactive. It's not perfect, but there is some reactivity there too, because Sqlite sends you an event when something changes. So yeah, if some other process wrote to a table, I would spot that had happened, quickly load it into the memory store, and boom, the UI is updated. And the sweetest implementation of this is with a project called CR Sqlite. This is another one you definitely need to link to in the show notes, which is built by another ex-Facebook employee, as it happens. His name's Matt, and he is at Tantaman, I think, on Twitter. And he has basically figured out a way to have SQLite synchronize using a technology called CRDTs. So if I save Tinybase to his database, that database can then be conflict-free replicated to other browsers or other servers, and that kind of all happens magically in the background. So yeah, I'm always on the lookout for other ways to persist this data. I think I can do Postgres next, probably, maybe Supabase, something like that. I will have a go at IndexedDB eventually. And PartyKit is another one that's kind of on my list of things to figure out. Can I use PartyKit as a way of persisting Tinybase change sets up and down, so that, yeah, you get that pure multiplayer experience with a Tinybase-based app. That's like my mental roadmap of all the shit I have to do.
Yeah, no. That was really awesome. That was really awesome. I saw a tweet the other day that was talking about Tinybase and PartyKit and a few other things as a really good local first but multiplayer setup. So yeah, I mean, I definitely think that would work really well. Also, this is really exciting. I feel like, especially around SQLite, there's so much really exciting integrations with SQLite. I feel like there's a real groundswell of support for this, both really great extensions that's coming out, like the official sort of SQLite WASM extension, but also things like this that sync to SQLite, and then cloud services so Cloudflare has their own SQLite service, and Fly.io has a sort of syncing service, and it's really cool to see all the support, especially with SQLite as sort of a base data store abstraction, because it's really solid tech.
I would love it if it just had one more notch of granularity on its reactivity. That's the only kind of request I have. At the moment, I know when a table's changed. I would love to know that just a cell had changed. That would be sweet, which I think you can't do out of the box at the moment. But yeah, one day, if we keep pushing this reactivity thing, maybe it'll get there.
Yeah, I could definitely see it. I wonder if that's achievable with an extension, or if it has to be a core change.
We think it is. I've been chatting to Matt a lot about this. Someone's actually done something similar, I think, in Swift for native iOS apps, Can't remember the name of the project now, but I can maybe find it for you later. So yeah, it is doable. And then you've got like full end-to-end reactivity, and that's I think that's a big deal.
Yeah, no, that'll be huge for sure. So do you use any WASM with Tinybase? Just out of curiosity.
Nope. I mean, obviously, when my Sqlite is running in WASM, I connect to that. But no, Tinybase itself is vanilla JavaScript, pretty modern, which is kind of like another opinionated thing that I did. And it's tiny. I don't know if the name kind of was the clue, but I've really optimized to try to make this thing as small and light and fast as possible. WASM might be able to make it faster, but like it's already pretty fast, so I'm not necessarily leaning into that. It's a whole other podcast, by the way, talking about like how to like ultra minimize things. That's been a lot of fun. No runtime dependencies is the trick, right? So it has no dependencies whatsoever, it's like, I don't know, 5K or something compressed, which is pretty good for what I think it's pretty good for what you get. And I don't really have any need to do anything too fancy. It's all just maps and sets wrapped up in a nice API.
Yeah, I don't think you'd be able to get it that small if you were on WASM. Like, they aren't 5 kilobytes big. They're much bigger than that.
Yeah, no, exactly. Just the whatever the loader, probably bigger than that. So I think if you ever wanted to run something like Tinybase in a server environment, which of course you could, maybe you'd want to have some kind of Rust-based implementation, but like I'm not racing to do that right now. It's plenty fast, I can assure you.